All right, let's dive into something really fascinating today. We're going to explore a pretty wild question. What on earth can the brain of a person born blind teach us about the minds of artificial intelligence? We're digging into a paper that connects these two worlds in a way you might not expect, and it reveals something deep about the very language we all use. Let's get into it. So, the whole thing kicks off with this really powerful idea. Symbols, words and concepts, they aren't these rigid, fixed things. The paper calls them topological folds, which is a fancy way of saying they're more like clay. They can be bent, stretched, and reshaped by our actual direct experience of the world. They're not set in stone. And that immediately leads to the central question for this whole explainer, right? What happens when the symbols you're given, the language everyone around you is using, just doesn't line up with your own lived reality? To even begin to answer that, we first have to look at the language we all kind of swim in, a language that, it turns out, is absolutely filled with what the paper calls winner symbols. So what is a winner symbol? Well, think of it like a metaphor that's gotten so popular we've forgotten it's a metaphor. And almost always, it comes from the dominant sensory experience of a culture, which for most of humanity is sight. We just sort of assume these visual symbols make sense to everybody, everywhere. And once you start looking for them, you realize, oh my gosh, they're everywhere. We connect understanding with seeing. We connect knowledge with light. We say, I see what you mean, or we talk about a bright idea. This way of speaking is so deeply baked into our language, we just treat it as the default. But should we? So, what happens when you have to navigate this world jam-packed with visual symbols, but you've never actually seen anything? This brings us to our first major topic, the absolutely incredible way the brains of congenitally blind individuals handle this very problem. The investigation starts with a really striking statistic. Researchers discovered that for individuals who are congenitally blind, nightmares make up roughly 25% of all their dreams. Now, watch what happens when you compare that to the sighted population. Their rate is way down at around 6%. We're talking about a difference of more than 4 times. That's a huge gap, and it just begs the question, what is really going on here? Well, the conventional thinking is that it's about practicing for physical threats, things like falls or bumping into things. But this paper proposes something much, much deeper. They call it the symbolic strain hypothesis. The idea is that the nightmares could be a side effect of the constant mental work, the cognitive load, of translating a visually obsessed language into a non-visual world. This constant translation creates what the authors call a symbolic mismatch. It's this persistent gap between the visual language of the culture and your actual direct reality, your world of touch, sound, and your sense of space. And this is where we see the brain's absolutely brilliant solution. And it's not a flaw, it's an incredibly sophisticated skill. The brain basically runs this 3-step program. First, it disentangles a word like see from the physical act of seeing. Second, it rebinds that word to other senses. So maybe to see comes to mean to understand through touch or description. And third, it constantly tracks the gap between its own refined meaning and how everyone else is using the word. Okay, hold on to that idea of symbolic mismatch, because we're about to make a sharp pivot. We're jumping from human neuroscience straight into the world of artificial intelligence, and you're about to see the connection is, well, it's kind of uncanny.
I mean, really, what could a human brain and a large language model possibly have in common? At first glance, they seem like they're from different planets, but this paper shows us there's this powerful and frankly unexpected parallel.
And here's the kicker. Large language models are, in a very real sense, symbolically blind. Think about it. They've learned everything they know from text, and only text. They've read billions of our words about light and darkness, but they've never actually experienced either one. They've inherited all of our visual winner symbols with absolutely zero real-world grounding to back them up. And this slide right here, this is the aha moment of the entire paper. For a congenitally blind person, their field of experience, touch, sound, space, is incredibly rich, but the language they inherit is biased. So for them, their field is richer than a lexicon. Now look at an LLM. It's the complete opposite. It has this massive, sprawling lexicon that is way richer than its field because its field is nothing but text. Both of them are wrestling with a profound symbolic mismatch. So, if we understand this deep parallel, what can we actually do with that insight? This is where the paper shifts gears, moving from just diagnosing the problem to proposing a potential solution for building better and maybe even more honest AI. The paper proposes a new kind of architecture called Reset-Gated Intelligence, or RGI. And the big idea is to completely change the AI's goal. Instead of just trying to give us the answer it thinks we want, its job becomes to actively tell us when it doesn't really understand, to flag its own symbolic mismatches. So what would this actually look like? Imagine asking an AI about a bright future. A normal model would just spit out some generic positive stuff. But an RGI model would first say, hey, just so you know, I've only ever read this phrase in books. Then it would ask you, what does bright actually mean in your experience? And from that conversation, you and the AI could actually co-create a new, more honest symbol together. The ultimate vision here is a totally new kind of language, what the authors call a natural typology language. The idea is that instead of flat words, we'd use glyphs, symbols that aren't just text, but are actually shaped by real experiences. A shared language built from touch, sound, and space that could be understood by different kinds of minds, whether they're human or artificial. Okay, so let's zoom out one last time. Why is this whole idea of mismatch so important? What are the bigger takeaways here for how we think about truth, symbols, and just communication in general? And here it is, the key insight, that remarkable process that happens naturally in the brain, taking symbols and separating them from their inherited meanings, that can be our instruction manual. We can use that blueprint to design AI that doesn't just blindly repeat our cultural biases, but actually helps us see them more clearly. And the paper is really clear on a few ethical points. This is not about romanticizing blindness or just using it as a handy metaphor. The whole idea is to learn from a sophisticated cognitive process, and the authors stress that any of this work has to be done with blind communities, not just about them. It's all about partnership and respecting lived experience. This final quote just brings everything full circle so perfectly. The very skill we are trying to engineer into our most advanced AI systems, this ability to refine symbols to better match reality, might be something human brains have already been mastering for millennia, purely out of necessity. And that leaves us with one final powerful thought to chew on. What if those moments where language breaks down, where our symbols don't quite fit our reality, what if that isn't a bug? What if it's actually a feature? A built-in signal that's telling us it's time to stop, to think again, and maybe to build a richer, more honest way of understanding our world and each other.